Well, let's apply what we just learned. We are going to use this formula to calculate the area of one petal of the rose curve. Now there are 4 petals here, so we are going to assume at first, just to start our thinking, that to get one petal we are going 1/4 of all the way around, which would be 1/4 of 2 pi, which would be pi over 2. Good assumption, doesn't always work in some cases, but yeah, we're just gonna go with that for now. So 1/2 from somewhere to somewhere, we'll finish our assumptions in a minute, of the function, r as a function of theta, 2 sine 2 theta squared d theta. So before we finish this, let's actually, again, we need to know the interval, so we can't finish it until we know the interval. So what I really want to do is find out where this starts and where it ends. So if you graphed it, I say where. Here's what I mean. What is the theta value when this thing begins graphing, and what's the theta value when it finishes graphing? Just this one piece right here, just that. All right, watch what happens. Right here, right now, there is no other place I'd rather be. It's a good song. Anyway, right here, right now, at this moment, we have not yet begun to swing this angle around, okay? So we're graphing in a polar way, polarly, if you will. So the radius is 0 at this moment, and then as the radius begins to, let me rephrase that, as the angle increases, as theta changes, the radius increases and then comes back in towards a radius of 0. So here's the question. At what values of theta, the answer is going to go here, do we have a radius of 0? So 2 sine of 2 theta is equal to 0. Solve that. So let's solve it. So we'll divide by 2, so sine of 2 theta is equal to 0. And then we're going to say, well, sine of what is 0? Well, the sine of what is 0 means, well, then 0 radians, basically. Pi radians would give me a sine value of 0, or 2 pi radians, or 3 pi radians, and you can see where this is going. But this is not equal to theta. This is equal to 2 theta because of that guy right there. So if we divide all these by 2, then we're going to have 0 over 2, pi over 2, 2 pi over 2, 3 pi over 2, and then so forth and so on. So our first assumption was correct. Swinging all the way around to draw this thing, we would go 2 pi, but we only want to go 1/4 of 2 pi, which would be pi over 2. So from 0 to pi over 2. Just to confirm, I'm going to grab a calculator and demonstrate a little bit of confirmation here. Watch this, it's going to be so exciting, you'll love it. I press y equals, and that's not what I wanted. Well, it is what I wanted, but I'm in the wrong mode, so let's change it. The mode is going to be polar. Now we'll press y equals. If you have stuff in there, clear it out. I do, so I will. And we have 2 sine of 2 theta. And I want to graph it. But you know what I want to graph? I'll tell you what I want to graph. I want to only graph from 0 to pi over 2, just to confirm my suspicions. So 0 to pi over 2. And we graph. And it's hard to see. So I'm going to go to a standard window. I'm about to make a mistake, but I'm going to do it on purpose. Zoom 6, zoom standard. And oh, there's the whole thing. Oh no, I made a mistake. I only want one of the petals. So when I pressed zoom standard, it adjusted the theta values as well. It went from 0 to 2 pi. That's the default. So 0 to pi over 2. Have to do that again. I'm going to adjust the x's and the y's too. You can see here on this graph we go from -2 to 2. On the test, don't spend too much time confirming things like this. We're just kind of playing right now just to gain some calculator fluency and some polar fluency and calculus fluency and such. Oops, I never pressed a graph. There we go. That was it. That was it, from 0 to pi over 2. Now we can type this in, and we will type that in. So here it goes. 1/2 math 9, 0 to pi over 2 of that function, which is stored in R1. So alpha trace R1 squared d theta. And I got 1.5709. Now that may not look too familiar to you. Maybe it does, maybe it doesn't. That may not look too special to you either, but I want to show you something cool. So I'm about to write the answer, but I'm not going to write that. Multiply that by 2. What do you get? Oh, This that you just got is pi over 2. All right, one more random thought. I could get the exact same answer of an area of pi over 2, not to be confused with this pi over 2, which was part of the interval. I could get the same area if I go from pi over 2 to pi, or pi to 3 pi over 2, or 3 pi over 2 to 2 pi. It's going to give me the same thing. It's just a different petal that I'm shading. Okay, now we're going to calculate the area of one petal of this rose curve given by this equation right here. And so let's start with the standard stuff that we've been doing. 1/2 integral from somewhere to somewhere. Don't assume too much yet. Sine of 3 pi. Square that thing. D theta. It's going to equal something. All right, here goes. You're going to love this. It's going to be frustrating, I know. The last one, we had one petal out of 4, because the whole circle made 2 pi. Well, one petal out of 3, because the whole circle makes 2 pi. So what I really want to do is decide, and y'all, you're going to be so mad when this happens. You might cry. What I'm going to do is take that 2 pi and divide it by 3. So it sounds like from 0 to 2 pi over 3 would be my interval. You can tell from my tone of voice, it's not. Okay, so let's graph this thing. So sine of 3 theta, there's that. And we're going to press window and go from 0 to 2 pi over 3. 0 to 2 pi over 3, and I'm just going to press graph. And, what? Wait a minute. That's not one petal, that's 2 petals. Your logic sometimes doesn't work in these things. Not to insult you. Your logic doesn't sometimes work. Well, sometimes you just got to be careful with it, all right? So here goes. What I want is to find out where this ends and where it begins and where it ends. I said that backwards. So sine of 3 theta equals 0. Where does sine equal 0? Well, glad you asked. That happens at 0 and at pi. You just saw this. And at 2 pi over 3, or 2 pi, sorry, thinking ahead. 3 pi, divide by 3, so 0, pi over 3, 2 pi over 3. I know that looks familiar. We just tried it, but notice this first interval from 0 to pi over 3. And then 3 pi over 3, that would just be pi, . Okay, test it one more time. If I went from 0 to pi over 3 instead, that's what I want. All right, good to know. Good to know. So 0 to pi over 3. Yeah, got it. Now let's do this. Let's do this. Math 9. Whoops, messed up. Calculator learning time. I should have put the 1/2 in there. I could divide my answer by 2 when I'm done, but I don't want to. I'm going to go back, and so once I started it was here. I'm going to press the back arrow because I'm like, I left something out. Second and INS, insert. Now whenever I type, it's going to just push everything over. So 0.5, and now we'll move our arrow and get started again. Handy little trick. Now you know. And then our 1 squared, no, not to the -1, to the +2, d theta. And we're going to press enter, and we're going to get that. And you can write that if you want to, but ain't nobody want to write that because, you know, you found out on the last one this was really pi over 2. So I wonder what this is. You don't have to do this. I'm just showing you how much fun this stuff can be. I wonder what that answer is. I happen to know. So here's what I'm going to do, actually. I'm going to divide that answer by pi, and I get this, which is 1/12. So if you really want to know, I calculated this slightly different this time. This is really pi over 12. Fun, isn't it? All right, let's do one more on the front. And this one's going to be very tricky, so let's just start with what we know. 1/2 of the integral from somewhere to somewhere of 1 minus cosine theta d theta. Now, there's a lot we can do here to try to figure this out, but let's think kind of logically. If we were to graph this by hand, like we did in a previous lesson, we would have a table of values, and we'd plug in a theta, and we'd get started, and we'd plug in another theta, and we would graph as we go, graphing as we go, graphing as we go, graphing as we go, okay? So we've done this. We had an r theta, and then we'd plug in theta and crank out an r. I have that backwards, sort of. Anyway, beside the point. So if I plugged in 0, I'd have 1 minus cosine of 0, that's 1, so 1 minus 1 will give me 0, and that's great. That gets this whole thing started, and then we get pi over 2. Pi over 2 is, well, let's see, pi over 2, Cosine pi over 2 is 0, so 1 minus 0 is 1, which is actually here. The scale on this is hard to see, but this is actually positive 1. This is actually negative 1. This is actually very hard to see, but this is negative 2. It's going to come in handy later, trust me. And so, again, plugging in values using r and theta, sometimes you can have them switched in this context because it's a little bit different from x and y. So, all right. Then you get over here and you plug in a pi. Why are you plugging in a pi? Because your angle swung this far over. So you plug in a pi, you have 1 minus cosine of pi. Cosine of pi is negative 1, so 1 minus negative 1 is 2. Okay, but I'm going to negative 2. Be careful, all right? I'm going in this direction, but when I graphed this point, I would swing around, pi, and then I would go in the direction I'm facing 2. So that's why it's this. This actually starts at pi. I'm going to prove it to you in just a minute, but it starts at pi. And then it would come back around, and it ends at 2 pi. So that is it. Whoa, I forgot to square this. Y'all been staring at the video saying, square it, square it, square it. Okay, so if you're a little bit lost, let's start this train all over again. 1 minus cosine of theta. Oh no, the lights just went out. No, we'll go with it. I want to know where this thing has a radius of 0, which is where this thing is at the origin. So we're going to set it equal to 0 because this is equal to the radius, and I want the radius to be 0. So I'd have 1 equals cosine theta. Cosine is equal to 1 at lots of places, but that would be places like 0 or 2 pi or 4 pi. Well, we're not going to get that crazy with it. So 0 to 2 pi. So at 0 and at 2 pi and at 4 pi and at 6 pi and all the even pi's, you're going to be back at the origin because your radius is 0. However, what I want, and this part can really trip you up if you're not careful. It's tripped me up before too. I want 1 minus cosine of theta to equal, now you might say negative 2, but actually we want to be facing that direction when we go there, so it's going to equal positive 2. And so we'll move this over. That gives me positive 1, so cosine theta is equal to negative 1. Well, where is cosine equal to negative 1? Well, that's going to happen at pi and at 3 pi and at all kinds of pi's, but we're just going to be dealing with pi, okay? So you might say it's from 0 to pi, and you wouldn't be wrong in calculating your area, but technically you haven't dealt with this region right here. So it is from pi to 2 pi. One more time, let's graph it. There we go. We're going to graph it just to confirm. I said I'd prove it. Whoa, no. So there it is. Window from pi to 2 pi, and that's it right there. Graphed what I needed to graph. That was the one. All right, let's type that in the calculator, see what we get. You're going to love this. Man, you're going to love this. 1/2, try it again. 1/2 math 9 from pi to 2 pi of R1. It is squared d theta, and you get that answer, and you're probably like, well, what's so special about this one? Would you be disappointed if I said nothing? You probably would, because it's not nothing. It's pretty special. Now, there are some that are just truly not special, and they're just big, disgusting, clunky answers, but this one's kind of special. I'm going to divide by pi because I want to. See it? That's 3/4, so this is 3/4 pi.